All right, so building on what you did yesterday when you were actually finding those special right triangle sides, I did say specifically that the ones with a hypotenuse of 1 were going to be very, very important because they deal with our unit circle. Okay, and by now you should have done trig lesson 2b, where you were actually doing the sine, cosine, and tangent of triangles, and we're going to put all that together with this last part of, or with this part of trig lesson 3, and that is to construct our unit circle using all those degrees and radians and the special triangles that we're talking about now. So what I want you to do for the bell ringer is go ahead and fill in those two missing sides on each one. Please make sure you write them correctly. You know, you simplify the root and write it the way you're supposed to. Okay, pause the video, and then, you know, we're going to go ahead and move on because this literally is going to be the first part of your notes today, is getting those side measurements. Okay, so you should have paused the video. Okay, and knowing that the hypotenuse of the 30, 60, 90 is 1, that makes the side opposite the 30 1/2, half of that. And this 1/2 times the square root of 3, and I told y'all in the video yesterday to write that as the square root of 3 over 2, because that's what that means. 1/2 times the square root of 3. All right, for the 45, 45, 90, you should be dividing by the square root of 2. Well, 1 over the square root of 2 is not allowed. You actually have to write it as simplified, the square root of 2 over 2. And both of the sides should be the same. Okay, so going into our lesson for today, you need to make sure you're remembering those. Very, very important. So let's talk about the sine, cosine, and tangent of those angles and those sides. Okay, here we have it all set up as far as the 30, 60, 90. All right, so we're going to go ahead and tip in here as far as if I want, let's say I want to start with a 30-degree angle, okay? So that would be B, right? In this case, it's B. If I wanted the sine of B, okay, sine being opposite over hypotenuse, that's 1/2 divided by 1. It's really just 1/2, okay? And if I wanted the cosine of B, that would be adjacent, so root 3 over 2 divided by 1, which means it basically just stays the square root of 3 over 2. And that's for your 30-degree angle. If I wanted the 60-degree angle, we're looking at angle A now, and if I wanted the sine of that 60-degree angle, sine again being opposite over hypotenuse, that would be the square root of 3 over 2. And the cosine of that would be 1/2. 1/2 divided by 1 is 1/2. Okay, very, very important because these are actually going to be part of our unit circle. They give us very specific measurements and very specific things that we do with them. Excuse me, goodness. Okay, so keep those, make sure they're written down in your notes for the 30, 60, 90. Okay, very, very important based on these measurements. All right, so let's take a look at the 45, 45, 90. Okay, we filled in the sides, so the hypotenuse is 1, and each of the two sides is the square root of 2 divided by 2. So again, we're going to look at, and A and B in this case are going to be the same, so it really doesn't matter which angle I look at since they're both 45 degrees. If I wanted the sine of that 45-degree angle, pick one, doesn't matter, opposite over hypotenuse is going to be the square root of 2 over 2. And the cosine of that is also going to be the square root of 2 over 2 because the sides are the same. Okay, now these are very, very important. We're actually going to be filling in, or you're going to be filling in unit circles today using this information. Okay, so let's take a look at what I'm talking about when I say a unit circle. This is a circle with a radius of 1. Okay, and we put it at 0, and that's how we show all of those angles that we did in like standard order, like or standard form, where you were drawing them either clockwise or counterclockwise for positive or negative. That's the unit circle. Okay, it's going around the coordinate plane, the x and y plane, and it's a circle and a radius of 1. Okay, so there are 3 things that go on our unit circle, and those 3 things you've already learned. Those are your radians and your degrees for specific measurements. It's very specific angles that go on there, and it's all based on our special right triangles. And then using what we just found out as far as sine and cosine of our special right triangles, we're actually going to figure out some other information to go on to our unit circle. Okay, so there are very specific measurements for it. There are 4 degree or radian measures, because you can write them either way, that deal with the axes, and that is right here, right here, right here, and right here. And we were doing that a little bit when we were going, like drawing the circles, or the angles rather, in standard position. This was like 0 or 360 or 0 or 2 pi, depending on if you're in degrees or radians. And this was 90 degrees, or, pi divided by 2. This was 180 or pi. This was 270, or 3 pi over 2 is actually how we write it, because it's 1.5 basically around the circle. And then all the way around the circle was 2 pi. Okay, so very specific measurements. We get 1 for each of our axes. And then notice that there are 3 in each quadrant. Okay, these are all related. Okay, and there's a very specific way that they're related. And I'm going to be filling in the first quadrants, and then you, for your homework or your assignment in Canvas, are going to be filling in the rest of it. Okay, so very, very specifically, I know that this is 0. We're going to start with degrees for right now. 0 or 360 degrees, because it's either the start or all the way around one trip around the circle. Okay, take a look. I know also again that this is 180, which is 1/2 of our circle, right? Now, if you take a look at these measurements, at where the little tick marks are, there's a very specific reason they're there. This cuts each of the quadrants in half. Okay, imagine if you were to take a pizza and cut it into 8 slices. Okay, that's what you would be doing. You'd be cutting it into fourths, and then you'd be cutting each of your fourths in half. Okay, so we can actually do this very, very easily based on what we know the whole circle is. I can take 360 and divide it by 1, 2, 3, 4, 5, 6, 7, 8, because there's going to be 8 for each quadrant. Or I can divide 180 by 4. Okay, half the circle by 4. And that's a very important concept, because when we switch over to radians, remember, everything is based in terms of pi, right? That 180 and pi are the same thing. So if I take and I divide 180 by 4, I get 45. Okay, so that is a 45-degree angle, right? And these little midpoints are basically the same thing. They're 45-degree angles in each quadrant. Your goal is to figure out what those actual degree measures are. And all you have to do is think about it in terms of each one is 45 degrees. So if it goes up to 45 to here, you go up to here, well, 45 plus 45 is 90, and that is one quadrant. And then you keep going all the way around to 360. Okay? So that is the little in between the center marks. All right? What if I talk about these ones on the outside? Okay, so let's get rid of this one real quick. All right, so if I talk about these on the outside, okay, these are a little bit different. And believe it or not, those are actually 3 equal pieces, even though it doesn't look like it. So imagine, instead of cutting your pizza into 8 slices, or half your pizza into 4, you're now cutting half your pizza into 6, okay? And these all have the same measurement. Well, 180 divided by 6 is 30, which means that the first degree mark is 30 degrees. I skip past my 45 and I get to the next one, the next of the thirds, and that's going to be 60 degrees because, 30 plus 30 is 60. If I add another 30 to that, I get to my axis, and there's my 90-degree angle mark again. Okay, so these are dividing your quadrants into chunks of 30 degrees. And notice there's our special right triangles, 30 and 60, and then the 90s ends up being like down here. And then this is your 45. Okay, so those are very, very important measurements. All right, your job is going to be to fill in the rest of these in degrees, and now we're going to do it in radians, and then we're going to talk about the sine and the cosine. So very, very important. And do it in Canvas. I do want them written on the circles in Canvas, but do yourself a favor. Draw them in your notes and study them because you're going to be using them over and over and over again. It's better to be able to flip back and look at it. All right, so let's try it in radians now. Okay, in radians. So same thing. This is either going to be 0 or 2 pi. This is going to be 1 pi. That's half our circle. We already talked about this being pi over 2, or half of pi, because you're cutting it in half. And then I told you very specifically that this had to be written as basically 3/2 pi. Okay, that's how we write our radian measures. Okay, same exact cuts, same exact pieces. Only instead of saying that we're cutting 180 into 4s, right? Our 4 is right here. We're going to be cutting pi into 4s, which means each one of these marks, each one that represents or goes with 45 degrees, is pi over 4. Okay? And this is where also being able to add fractions without a calculator is going to help you. Because if this represents 1 pi out of 4, like one piece that happens to be pi out of 4, and I go to the next one, remember in degrees it was 45 and 90, right? You double it. Well, what's pi over 4 plus pi over 4? It's 2 pi over 4, and you reduce the fraction and you get pi divided by 2. Okay? And again, it's going to be that way all the way around. You're going to keep adding pi over 4 all the way around, including your axes, because you're going to hit that both times. Keep adding pi over 4. Please be sure you reduce your fractions. Okay? I don't want to see any non-reduced fractions. Okay, so that's for the pi over 4 one. And again, that's the exact same thing as a degree of 45 measurement. All right, so let's try the ones where we know we're cutting it into 30-degree chunks. And again, may not look it, but these are all the same. It's just my bad drawing. Okay, so 30 degrees, and we said we were cutting half of our pizza into 6 pieces. So that means each one of those is worth pi over 6, right? Divided into 6 pieces. Okay, so that's 30 degrees, and it's pi over 6, because if you were to convert it, that's what you would get. If I add a pi over 6, skip over to get to the next one. Remember, this was 30 and this was 60, so I'm adding another to get there. What's pi over 6 plus pi over 6? It's 2 pi over 6, which is pi over 3. And you're going to keep doing the same thing all the way around. You're going to keep adding pi over 6. Every mark except for the ones in the middle. Okay? And you're going to fill in your circle with all of the radian measures. And I've printed out in the assignment in Canvas 3 separate circles. One for the degrees, one for the radians, one for the sine and cosine. Okay? And that's what we're going to get to next. And that's the little bit of the harder part for this. But this, you should just be able to fill in the circles with those measures. If you want to pause the video and go and do those 2 circles now, that's fine, and then you can come back and do the sine and cosine afterwards, because that's where it gets a little interesting. And this has to do with those special triangles and finding the sine and cosine of those special triangles. All right, so let's start with 30. 30 degrees, we know, is right there. We already know that that's the 30-degree mark. We already talked about that. if I were to make, let's make that a little bit better. If I were to make a right triangle that stopped at that 30-degree mark, right? Just, drop a little line down. Let's make a better right triangle than that. Okay, we make a right triangle here, right? That's going to be, you remember about your central angle theorem back from geometry? That's going to be my 30-degree mark because that's my 30 degree on my outside of my circle. They match, right? So that's going to be the 30. That's the 90. That's going to be the 60. And remember, this is a unit circle. That means that the hypotenuse is 1, right? That's what I said, the radius was 1. So if that's the 30-degree mark, and that's the small angle, that's your, your base point, and your hypotenuse is 1, that means this measurement right here is a half. That's how tall that triangle is if I draw it at the 30-degree mark. Okay, it's a half unit tall. And how long is it? Well, if that's across from the 60-degree angle, it's square root of 3 divided by 2 long. Okay, so here's where it gets interesting. If I were to consider this as a point in space, this 30-degree mark, I would go over square root of 3 over 2 and up a half, right? That's like an x and y coordinate. So your x coordinate for that point would be the square root of 3 over 2, and your y coordinate would be a half, right? And that's, if I was, like I said, if there was a grid behind here and we could show that we were actually moving on an XY grid, this point on that one unit radius circle would have this x and this y coordinate. Okay, and here's where it gets interesting. That x and that y coordinate, right? Go back to your special triangles. We know for a fact for the 30-degree angle that the sine of that 30-degree angle is a half, and the cosine is the square root of 3 over 2. Okay, this is why the unit circle is so important. Take a look. I'm talking about 30 degrees right here at that coordinates, right? Well, that must mean that this x-coordinate is the cosine of that 30, and the y-coordinate is the sine of 30. Okay? It's a lot to wrap your mind around, but that triangle that I make that corresponds to that 30-degree mark has this as an x and a y coordinate, right? And it happens to be the exact same thing, because my, hypotenuse is 1. It happens to be the exact same thing as the cosine and the sine of 30 degrees. Very, very important. Okay, so let's go ahead and do the 61. Same exact thing, only remember, this is the 60 mark up here, right? And if I'm going to draw a right triangle from that one, okay, that means now this becomes the 30-degree down here because that has to be the 60-degree here, right? It has to go across from the 60-degree mark. So, again, going with that same measurement, if the hypotenuse is 1, across from the 30 is a half. That would be my x value this time. And across from the 60 would be my root 3 over 2. So it's the same exact thing, only backwards. Now my x value is a half, and that again is my cosine of 60. If you go back and look, cosine of 60 degrees is a half. Okay, and then my sine is the square root of 3 over 2. And this is just a way of, when we start solving trig equations and we start graphing them, you're going to need all this information. I'm also going to show you another neat shortcut that you can use with your hand. So, all right, so this one's getting kind of crowded, but I don't want to delete it. Okay, so let me go to another circle and just use this one for 45. We already did degrees, don't need that. All right, so let's go ahead and do the 45 one. All right, for the 45 degree, we know it's right there, right? 45 degrees. Okay, draw your right triangle inside the unit circle. And it doesn't matter, both of these are going to be 45, right? So again, to get to that place in space in the coordinate plane, I would go the square root of 2 over 2 over, and the square root of 2 over 2 up. Okay, so that would make its x and y coordinate the exact same thing. And again, it is going to be the cosine and the sine. And this is kind of important in that cosine goes with the x and the sine goes with the y. It's going to make more sense later when we start working with it. But the cosine is always the x and the sine is always the y, and it's the way the coordinates work around the unit circle. Okay, so before I leave you on this and I can hear the, oh my god, I'm never going to get this, let me show you a neat little trick. And this is something you're going to want to draw on your paper real quick. Draw a big circle and put the tick marks in it, because I want to show you how this is going to work. Okay, these are the exact same coordinates all the way around the unit circle, and they're all based on those same measurements. Okay, so that being said, all right, those 45s, there's a reason they're all marked red, and it's not just because they're all, you know, adding 45 and adding 45 and adding 45. All four of these have the same x and y coordinates. The only difference is here both my x and my y are positive. Here they're both negative, right? Well, here x is negative and y is positive. And here x is positive and y is negative. So if I told you this is root 2 over 2 for my x and my y, then these are also all going to be the square root of 2 over 2. They're just going to be some positives and some negatives. No big deal. Now, let's see about the other ones. The other ones, well, the ones that are the closest to the y-axis are all the same. Okay, and you'll hear me refer to these with my other pre-cal kids as bounce angles, because it's the same angle. Bounce it around the little square there, and it's the exact same measures. Now this one I think was 1/2 and then the square root of 3 over 2, right? For the x and for the y. Same thing for all four of those. Okay, and then the last one, let's pick another color. How about red? Might be able to see red. The four that are closest to the x-axis also match. And you're going to see it, it works this way when you put in your radians measurements, because these are all going to have a denominator of 6. These are all going to have a denominator of 3. And these are all going to have a denominator of 4. And they all match. So it's a good way to know that those sine and cosine, those x and y values, are going to match. All the ones that have a denominator 6, 3, or 4 are all going to match that way. Okay? And again, if you want to draw these lines for yourself on your homework, that's fine. My recommendation, and I'm hoping you're taking this seriously, is draw it for yourself, because we're going to be using it over and over and over again. Okay, that's it for today. Like I said, you should have taken the quiz. That should have hopefully been first thing, and then finished up with Trig Lesson 2B, and done the SOHCAHTOA, and then gone on to this one. I will holler at y'all later.